There is a persistent myth on the internet that a few inventors have figured out how to run internal combustion engines on tap water. The intuitive logic makes a certain amount of sense. Water is plentiful, and 2/3 of its chemical structure is made of highly explosive hydrogen. Physicists and thermodynamics experts classify these devices as pseudoscience. Because these engines claim to generate more power than they consume, experts label them as outright scams. This confusion stems from a misunderstanding of what a water molecule actually represents. It is often viewed as a potential fuel source, when its chemical reality is exactly the opposite. To understand why an engine can never run on water, we have to stop viewing the liquid as a raw ingredient. Instead, we need to rewind the clock and look at exactly how it was formed in the first place. This diagram maps out chemical energy states. Up here at the very top, we have our true raw materials, pure hydrogen gas and pure oxygen gas, existing entirely independent of each other in a highly energetic, volatile state. When you introduce a spark to these separated elements, they go through the violent process of combustion. They crash together to form chemical bonds, and in doing so, they expel a massive burst of heat and light outward. That release of energy is what pushes a piston or turns a turbine. But look at what happens immediately after that explosion. The newly formed molecule plummets to the absolute bottom of the energy scale. It is now completely inert. Water is the chemical ash left behind after the fire has burned out. The law of conservation of energy dictates a harsh reality here. You cannot extract energy from a substance that has already spent all of it. This is where the mechanics of the water-powered engine fall apart. These devices claim to use an electrical spark from a car's alternator to run a process called electrolysis, essentially forcing that chemical ash to split back into explosive hydrogen and oxygen. The flaw is the sheer effort required to do that. Ripping a stable water molecule apart demands an immense input of electrical power. The energy you spend splitting those water molecules apart will always be greater than the energy you get back when you attempt to burn that freshly freed hydrogen inside the engine. The math operates at a permanent energy deficit. Because systems naturally lose energy to heat and friction, it always costs more power than it gives. Consequently, an engine cannot use its own alternator to split water and run continuously on the resulting hydrogen. The laws of thermodynamics guarantee that the process will rapidly drain the battery until the car stops. This schematic shows the interior of a real-world hydrogen fuel cell vehicle. Notice the flow path. The system draws pure hydrogen gas from high-pressure input tanks, uses it for power, and then outputs water as the chemical byproduct. These vehicles do not attempt to split water on board. In modern engineering, water acts entirely as an energy carrier. You have to pay a massive electrical cost up front at a dedicated off-site industrial facility to isolate the hydrogen before it ever touches the car. To perform that industrial-scale water splitting, we have to harness massive external power sources. Vast arrays of solar panels gather sunlight to provide the heavy electrical lifting. Massive offshore wind turbines sweep the coastlines to generate the electricity required to sever those chemical bonds. And nuclear reactors are utilized to supply the continuous electrical brute force necessary to sustain electrolysis on a commercial scale. So when you see a hydrogen vehicle, the car is actually powered by the distant sun, wind, or uranium that split the water at the factory, not by the water itself. There is exactly one scenario in physics where water actually contains untapped energy, but it requires abandoning chemistry entirely and zooming down to the subatomic level. If you skip past the chemical bonds and look at deuterium, a heavier isotope of hydrogen found naturally in seawater, you can force those atomic nuclei to fuse together. That specific process, nuclear fusion, releases staggering amounts of power. But keeping a fusion reaction stable in a commercial power plant is still decades away, let alone shrinking a reactor down to fit under the hood of a commuter car. It has zero application in modern vehicles. Ultimately, humanity has to stop viewing the oceans as free chemical fuel pumps. Water is not a raw combustible. It is an incredibly robust, clean battery, capable of storing and transporting the energy we harvest from the rest of the universe.